Hello and welcome. In this video, I will summarize the previous 4 cases where I calculated the flux through each face of the cube using the solid angle. So now our topic is flux through faces of a cube using solid angle. I will summarize here the 4 cases so that you can remember them easily, right? The first case is when the charge is at the center of the cube. So flux through each face of the cube will be same. Now flux through the cube is charge enclosed by epsilon naught, that is by Gauss's theorem. Now what is the solid angle subtended by each face of the cube? Since the charge is symmetric with respect to the faces of the cube, so solid angle subtended by each face here is 4 sine inverse 1 by 2. Therefore, flux through each face is equal to Q by epsilon naught. So it is omega divided by 4 pi, the usual general formula. So that is Q by epsilon naught 4 sine inverse 1 by 2 divided by 4 pi. So that is Q by epsilon naught 4 pi divided by, this is 6 4 pi, because sine inverse 1 by 2 is pi by 6. So it is Q divided by 6 epsilon naught. That is the flux through each face of the cube. So we can get it from this also if we divide the total flux by 6, because flux through each face is same. Now let's come to the case number 2, when the charge is placed at the corner of the cube. At the corner of the cube, the contribution of charge in the cube is only 1 by 8. So the flux through the cube is Q divided by 8 epsilon naught, right? Now, since these 3 faces, one is the back face, second is this side face, and third is the bottom face, they contain the charge, so flux through these faces will be equal to 0. Why? Because the field lines will be parallel to the plane of these faces, so flux is 0 through them. Now, solid angle subtended by other faces like this right side face, and then this top face and this front face, since these are symmetric with respect to the charge, solid angle is sine inverse 1 by 2. So flux through each face is Q by epsilon naught omega divided by 4 pi. So that is Q by epsilon naught sine inverse, this omega is sine inverse 1 by 2 divided by 4 pi. Sine inverse 1 by 2 is pi by 6. So it is Q by epsilon naught pi by 6 divided by 4 pi. So that comes out to be Q divided by 24 epsilon naught, right? Okay, so next let's come to the case number 3. Now in case number 3, I have placed the charge at the face center of the cube. When charge is placed at the face center of the cube, the contribution of charge in the cube is only half, because we need another cube to hide the charge completely. So the charge in the cube is Q by 2. The flux is Q divided by 2 epsilon naught. Now, the solid angle subtended by this face ABCD is different, because the charge lies on the axes of this face at a distance of edge length, whereas these 4 faces, that is the back face and the front face, top face and the bottom face, they are equally symmetric with respect to the charge. So we can write here solid angle subtended by ABCD is 4 sine inverse 1 by 5. So flux through ABCD, that is through this face, is Q by epsilon naught omega ABCD divided by 4 pi. So that is Q by epsilon naught 4 sine inverse 1 by 5 divided by 4 pi, right? So this is the flux through the front face. Now, what is flux through the top, bottom, back and front face? So that is omega ABFE, that is this ABFE. This is same for other faces also, is equal to sine inverse 2 by root 10. So that is flux through these faces is phi ABFE is equal to Q by epsilon naught 2 sine inverse, then it is 2 by root 10 divided by 4 pi. Similarly, for other faces, the flux will be same as this, whereas the flux through this face containing the charge is equal to 0, right? Okay. Now, let's come to the 4th part. The 4th part is when the charge is at the edge center. So the charge lies here at the edge center of the cube. The contribution of charge in the cube is only 1 by 4, because we need 4 cubes to enclose the charge. So equally distributed in the 4 cubes, the charge is only Q by 4. So the flux is Q by 4 by epsilon naught, right? Now, Since the charge is on the two common faces, that is this back face and this left face, so flux through these two faces will be equal to 0, right? Now, the top and bottom, they are equally symmetric, and this side face and this front face, they are equally symmetric. So these two faces will have the same solid angle. These two faces will make the same solid angle at the charge. So omega ABCD is equal to omega ABFE is equal to sine inverse 1 by root 10. So flux through these faces Q by epsilon naught omega ABCD divided by 4 pi. So that is equal to Q by epsilon naught 2 sine inverse 1 by root 10 divided by 4 pi. So the flux through this face and this front face will be same. So you can multiply this by 2 to calculate the flux through these two faces. Similarly, the flux through the top face and the bottom face can be calculated by knowing the solid angle is omega BCGF is equal to omega ADHE, that is equal to sine inverse 4 by 5, right? So then flux through these faces is Q by epsilon naught solid angle subtended divided by 4 pi. So that is Q by epsilon naught sine inverse, then it is 4 by 5. Multiplying this by 2, you can get flux through this face and bottom face. Multiplying this by 2, you will get flux through this face and front face. So that will be the total flux, and that total flux should come out to be Q divided by 4 epsilon naught. So this is the summary of all the previous 4 cases. So what you need to remember, only the solid angles subtended by various faces, and you can calculate what is the total flux through the cube and the flux through each